Would anyone of you guys like to kind of give a definition of a function? Yeah, so it's basically it's like code that's is organized, and it's generally best practices say it should be self-contained, and it executes some sort of action. Um, Now, the most important part of a function is that it can be repeated multiple times. So, for example, right, print's a function, len's a function, um, right, max is a function, min's a function. And as our programs get bigger and bigger, and our solutions for problems might get bigger and bigger, functions make the code a lot more manageable and organized. So yeah, I mean, right, code behavior inside of functions all the same. Um, right, you can use whatever you want inside of them, and those still work. So for example, if we were to just have def hello, right? We have here def, and then after, so this starts the function declaration. Then after we have the name of the function. And then after we have some parameters. So, for example, we could say like name, grade, whatever, right? And then after we can print. So this is the body of our function, is everything that is within this definition here. So then we can go ahead and use these, use whatever is given to us as an argument. And then after it'll just do that, right? Now, what's important to note here, but Python's pretty cool in the fact that it has something called first-class functions. So what that means is that functions can be are basically like any other variable here. So you can actually assign functions to well, they're the same basically, and you can return functions, and you can write anything you could think of as a variable. You can also do as a function. So for example, I can create a dictionary of functions. So I can say cool stuff equals that, and I can say like bye, and then I can just literally map it to hello. So now if I run this and I say cool at bye, I can actually run the hello hello function. So I'll say like, right. So this is pretty useful. It's also a part of quite a few functional programming languages. Some other ones that you might know are JavaScript. JavaScript's a pretty big one that allows that has first-class functions, and this really is just useful for just keeping your code concise, and also if you want to kind of generate some functions as you go, you can actually do that as well. But that's for some pretty complex solutions where you would find that slightly helpful. But of course, we don't need to use first-class functions in any of our solutions. It's just a really useful tool, and sometimes it makes our life a lot easier. Another thing that we need to keep in mind, of course, is the scope of the function, right? So if you guys know, if I say grade equals 12 here, actually let's say like a equals 12 here, I can print a here. However, if I print it afterwards, a will not be defined. Right, so it'll be defined within this context. However, it'll be defined in this scope, right? But it will not be defined in the global scope. Anything not within a function is inside Python's global scope, which means it can be accessed by any function as well. However, anything that's within a function is in the local scope. So that means that it's only accessible within that function and any sub-functions inside of that. Now, for global scopes, all that you really need to do is make sure that the variable is defined before you call the function. So if we do this, this will also work. Right, so it doesn't necessarily need to be in the same order defined, but it just needs to be, that variable needs to be defined before your function starts being called. Now here, for example, if I do this, right, so what you see here is that this a equals 13 is being printed right here. So this kind of overrides, the global scope. However, if we print it afterwards, you see that it doesn't actually modify it. So if we do want to modify variables inside a function, we have to use the global keyword. So once we do this, we'll actually be able to modify that within the global scope. And then after now, you can see that 13, we can actually change a directly here. Okay, now just keep in mind though that this is in regards to setting the values of variables, right? But if you aren't using the equals, you don't need this to be global. So for example, if I have a list here, right, I don't need to use the global keyword to say test.append B or whatever, right? If I do that and I print B, if I print test afterwards, you can see that I do have B inside of it. However, if I were to say test equals an empty list, not an empty list, let's say like A and C. All right, so now here Python detects that you are creating this variable inside the local scope. So then after it's going to error when trying to edit the global scope variable. So that's just a slight intricacy of Python there. But generally you don't want to do this, right? Because what this causes is this causes your function to not be very repeatable. Not in regards to your program here, but in regards to being able to copy and paste it directly into other programs. Right. So one of the biggest things that we want with functions is that we want them to be quite modular, so that we can literally just copy and paste them from any other program and they'll be working. Obviously, we can't do that for every single type of function that we ever write. However, in this case, right, especially if we're just modifying A or something, we could always return A and have A equal the return value of hello. Or we can do something else here, right? So generally, we'd like to avoid the use of globals and just kind of keep everything in this kind of black box, right? So that you don't really need to know exactly what the function actually does for using it. So for example, right, when you're printing, you don't actually know everything that's going on. You just know that, hey, if I want to print something, I just use the print command. Right, in reality, there's a lot of stuff going in the background, but you don't need to know that. And that's kind of the same thing that we want to use for functions whenever we're designing them, is that we should be able to just pop them in and just it does whatever it says it does without us needing to do other extra work. Next up is this return statement here. So return statements basically are essentially a way for your function to actually interact with the outside world, right? So after you're finished processing it, your function can return a value, and then after that value can be used by other parts of your program. Now, one thing to note here is that if you don't put a return, what it'll return, it'll return a none object, right? So if I set hello, let's say t equals hello, 12 here, I'm going to get that t is actually equal to, t is going to be equal to none, right? So t is none is going to be true. Okay. Now, if we say return, we can say return, for example, name plus str grade. So now we're returning the our name and our grade together. All right, and of course, and whenever you do return, it stops the execution of the function. So if I were to just say return over here, we wouldn't see the name and grade being printed out anymore. This is really useful for loops and functions. If you just want to get out of there, you could easily use a return statement and it just directly puts you out. So that could save you some time. All right, and just also, if you want to return multiple values, you can do so by just making it a tuple, right? There's no direct way of creating multiple return statements. Essentially, you just return a tuple, which is essentially an unmodifiable list with your program here. So then after here, we can just say t, and now we get these two values. Next up is something that you may not have done in your grade 11 comp sci class, and that is functions within functions. So what this lets you do is create functions underneath other functions. This isn't generally a feature for many other programming languages. So for example, in this example, we're going to be taking the exponent of a number. So what we can do here is we can say, all right, and remember, because Python has first class languages, that means that we can do this. We can return a function, right? So we're just defining the function here on that, we're returning it. And now what we can do is we can say, for example, raise, if we were to raise to the power of 2, we can say exponent power 2, and we want a function to raise it to the power of 3. We can do that. So this is what I was talking about when you kind of can generate your own functions. And now if we print this, you'll see that this is actually a function. And we can actually, so if we want to raise 2 to the power of 3, we can do that. Or if we want to raise 2 to the power of 4, we can do that as well, right? So as you can see here, you can see this is a local, right? This is a local of exponent power, and then we are just returning that function. So now we can use this function, the kind of this generated function, to be able to run our own stuff with it. So right, if we could do other things with this, whatever this definition here. Remember that when you define a function, it isn't being run. Just keep that in mind, and you have the full scope of everything above it, right? So whenever you're defining anything, whether it's like any type of function, you have access to you have the read-only access to the scope above it. So whether that be the function above it or the global scope, you have access to all of that. So this allows you to get information that's kind of hard-coded inside your function, but not really, because you can change it dynamically with your code. So for example, now if we were to also do raise underscore 3, we could say 3 to the power of 2 is going to be 9 here. All right, so now kind of moving on to what I wanted to really touch on today, and that is recursion. So recursion, well, okay, so comes from the Latin root recurrere, or I don't know really how to say that word, R-U-C-U-R-E-R-E, which means to run back. And that's kind of what a recursive function does, right? It runs back on itself. So let's take an example of a recursive function here. So in this case, this takes the factorial of a number. So for you guys who don't know, a factorial is essentially, so if I have, it's that exclamation mark you might see, right? So 5 factorial is, right, we're essentially multiplying by every single whole number less than it all the way until 1. So this is going to be kind of defined as this. So x factorial is going to be equal to x times x minus 1 times x minus 2 dot 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 all the way to times 1. Okay, so this makes perfect sense, right? We're just going to multiply it over and over again. So this would be a good target candidate for recursion. So what we can say here is, okay, what we have here is we're going to first multiply, right? So we're going to say, okay, if n equals 1, it's not 1. So we're going to multiply that by the result of the factorial of 4, right? Because 5 factorial is just 5 times 4 factorial, right? And then once we reach n equals 1, with the factorial, 1 factorial is just equal to 1. So we can just return that. We'll continue to call itself basically until some condition is met to return a result. All right, and this condition that right here is what we call a base case. And then after, what happens is the recursive call essentially adds to, it just keeps going over and over again until it reaches the base case. And the two properties that we should have for any recursive function here is that 1, it must have a base case, and 2 is that the recursion must approach and reach the base case. So that means that we need to be doing some sort of operation so that at some point in time, we will be able to hit the base case, right? If I just said n times n factorial like this, we're not going to be reaching the base case. So this is actually going to go on forever. And we're going to actually, like if we try this, Python's going to stop it actually, because our maximum recursion depth is exceeded. So there are limits in Python. So just be aware of that. So, I mean, we could definitely do this without recursion. It's just a little more complicated here. So this is our iterative version. So we're just going to basically use a loop and over it again. So factorial, right? We still get the same number. We still get the same result, but it's just a little, it works okay for factorial, but for some bigger problems, it gets super, super complicated. So here's this exercise that I want you guys to try. What I want you guys to try to do is to find all combinations of 0 and 1 with a length of n. So what that means is, for example, if I were to create a combination of 0 and 1 with length of 2, I'd have 0, 0, 1, 0, 0, 1, and 1, 1. Find a way, if you did this, and you might have done this in grade 11 already, so if you did, try to remember how to do it. So try to find a recursive way to do this. We're given some number or some length, you'll be able to find every single combination of zeros and ones. All right, so how to do this? The biggest thing, I guess the biggest thing that we should be thinking about right here is to think of it in terms of a string. Because if we were to think of it as numbers, we could do it in base 2, but it's a little more involved. We can just directly do it as a string. And since we're actually not going to be using the value at all, we can totally do that. So let's think about this. How would we build zeros and ones? Well, right. let's just kind of say, let's say we had 4 slots here available. So what we can say is, okay, so the first slot, we can say, hey, I want a 0 or a 1. So I can either choose a 0 or I can choose a 1. Right? And now let's kind of keep splitting over and over again. So now I choose a 0 or a 1. I choose 0 or a 1, right? 0 or 1, a 0 or a 1. Right? So now if I were to do this, I get a 0 or a 1, and then a 0 or a 1 or a 0 to 1. And then at the end, every single time, all right, I'll loop through this. This is one of them. Then here's another one of them. Let me change colors. Right, here's another one of them. Oh, that's a terrible color to use. Here's another one of them. Right. So we'll just be taking the output of this kind of this tree, right? So we can implement this in Python. So let's just call this bits. So this problem is also called bits. That's why I deleted Kevin's message there, is because they kind of gave it away. So what we can say is, okay, so let's keep track of what we have so far. So I'm going to call this has. And then after, let's also keep track of how many, it's like what we're looking for. So in this case, M is going to be our maximum length. So what's our base case? What is the case that will cause us to return a value? Yeah. So after it reaches, right, after it has reaches length of M, right? So that's the maximum length. So we can say if len of has equals M. So does that make sense to everyone? So that's our base case. So that's when we want to stop this branch that we're running. Okay, so if that's the case, we can just simply print as, right? And then we can just return. Now, for the normal cases, so how should we be? So now, given that our base case is that the len of has is equal to M, how do you guys think we should be approaching the base case? So what operation should we be doing so that we can grow closer towards that base case? All right, adding a 0 or 1, right? So let's do that. So let's do bits has plus a 0, comma, M, and then bits has plus a 1, comma, M. So now that we have that, we can say, all right, we're starting with nothing, right? And let's say we want to give it 4. As you can see, this generates every single variation possible. That's good. All right, so then let's move on to some practice then. So here's a list of practice questions. We're going to be taking up the first 2, hopefully 3 in class. And then after, the other 2 are going to be, I would like you guys to do that for homework. So similar to bits, we're going to go ahead and build a string. And this is really good for this question because we're only asked to use the digits 2 and 3. So that's very similar to our bits question, right? Where we're only using the digits 0 and 1. So we can kind of set it up very similarly to that. But let's think. So it's looking for the amount of numbers. So that means that we shouldn't be checking. Okay, actually, no. Let's just start, okay? Let's create a recur. All right, generally, I just like to call it recur. All right, so generally, I'll just call my recursion function recur. All right, so we're going to call it has, so it's going to be what we have so far. And then M is going to be our max, right? So let's think about this. So in this case, this would be one of the cases where I would use a global variable here because we need to take count. So I'm just going to say count equals 0, and we're just going to global this. What's going to be our base case? If the number is greater than n, right? Okay, so yeah, let's do that. So if since we're doing this as a string, we're gonna have to turn it into an integer first. Is greater than m, we're gonna return. Okay. So if it's not, what should we do first? Well, we're gonna increase the count, right? And now we can just build it, right? We can just say recur so far plus 2, right? Comma m. And then we can recur so far plus 3, right? So it's not really asking us for an order, so we can do this in whatever order we want. And then we can just get the number here. And then we can say recur. So if we were to just give this an empty string, right? If we evaluate this empty string, it's actually going to, sorry, not has. so far. Either I usually just use has or so far. But if we do this, right, that can't be cast to an int. So we're going to have to actually make that decision first. So we're just going to start off with a 2 and just do it that way. Right, so now I can just print count and I should get the right answer. Right, so let's say we were to give it some sample input here of 13. We're going to get 2, right? If we get 40, we get 6. All right, and this will pass. Let's move on to the second question. So this is going to be the recursion question. This is all of the recursion questions. This is ICS4P1. So this is the word scrambler problem. Okay, so the base case is when the length of the word is the same as the length of the original word. Okay, yeah, that totally works. Yep. Okay, so I'm just going to take it a bit of a different approach here. Is I'm going to kind of use a countdown where I'm going to say, hey, I have this many left. Since we're building a string, right? We're going to be building a string. We're going to have 2 sides, right? We're going to have letters that we've already used, and then we're going to have letters that we've not used yet. So has is going to be a string of the letters that we have used. And then left is going to be a string of letters that we haven't used yet, that we have to use left. So that means that if the length of our left string, right? So the number of characters that are left equals 1, that means that we're done, right? So once we have none left, we can print out what we have here. And then after, let's just go ahead and return this as well. So the this-based case makes sense to everyone. So we basically have a pool of letters, and they're split between letters we've chosen and letters we haven't chosen yet. So as our pool of letters we haven't chosen yet gets moved into letters we have chosen, that's going to be us building the string, right? So then once we are left with no more letters that we haven't chosen yet, that's when we stop. Next, we're just simply going to, so now every time we're building a string, right, what we want to do is we want to use every single letter that we have left. So to do that, we can just say for I in range, len of left. So, right, we're going to now go through every single letter and we're going to create a new branch off of that. So we're going to add the letter that we chose. And then after, we're going to remove that letter from the list of letters that are available. So next, we're just going to, so this is it. This is our recursion function. Okay, so all we're going to do is we're going to look at our has string. So that's going to be what we have already. And our left string is going to be the letters that we haven't used already. And all we're going to do is every single iteration, we're going to go through every single letter that we have left, and we're going to create a new branch, basically choosing that letter. All right, so then we're going to add that letter to the string that we already have, and then we're going to remove it from the ones that are available. Now we are going to get input. So the input here is just the seed, right? So that's going to be like the collection of letters. So we can just call this a seed. And we're going to create this, we're going to create a list from this input, all right? And the reason we're going to do this is so that we can sort it. Because remember that the question is asking for everything to be in a sorted order. Now we could add them to a list and then sort it afterwards, but that takes more memory and it takes more time. So what we want to do is we want to build it in a way so that it's going to be automatically in order, right? We're going to do that. So we're going to put all of the letters in alphabetical order. So that means that A is going to be chosen first, right? B is going to be chosen next. And the way recursion works is it operates in something called a stack. So that means that as we add, so what it means is that as we add operations to do, it's going to do them immediately. So it's going to be first in, last out, or last in, first out. So what that means is, for example, if I'm going to say recur has left, right? So it's going to recur. And then the moment it calls recur, it's going to go straight into the one that was just called. So it operates in a stack. So what that means is that we completely go through a branch first before we move on to the next branch. We don't finish this loop every single iteration. The first iteration of the loop, we're actually calling recursion, and then it's going to keep going down, 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 down. It's going to generate everything for A, and then it's going to move on to the next letter. Okay, so I'm going to assume that you guys understand that now. Because it's a stack, right? So that means it's going to always choose, because we have our list in alphabetical order and we're using a stack, right? It'll always choose the first branch that we finish is going to be the the first in the alphabet. And this is going to go down the list because we're iterating from left to right in this string over here. Next, what we can do is after that, all we do is we just call recur now, and we're going to give it the starting thing, right? And then after, we're just going to say, just give it seed. So now ABC, we get all the iterations. See how they're in alphabetical order, right? Because first it goes to A, then it says, oh, it's going to recur. So I'm going to go to the recursion, and it's going to say, okay, now I have B and C. Well, then after B is first, right? So then it goes down that branch again. And then the first iteration is going to be ABC, so it prints it out. And then there's the next one, so it's going to be ACB, and it keeps going down that list. So for homework, there are 3 more questions to go through, so please try those, okay? Recursion is a pretty important part of some of these algorithms that we're going to be going through. So if you don't understand exactly how stuff gets executed and how it works, you're going to be pretty lost pretty soon. So please make sure that you are practicing recursion and you understand how it works, all right? So I'm just going to end a little earlier here. We don't really have time to do another question. I hope you guys got what I was saying. Again, if you have any questions throughout the week or at any time, just feel free to just ping me in junior help, and I'll be happy to help you guys out. Okay, so if you guys don't have any questions, I'll let you guys go here. Again, please check out the questions that I posted. If you weren't able to get the ones that we did in class, please try those as well, but also check out the other 3 that we weren't able to get to as well, okay? So next week, we're going to be starting on some searching algorithms, and that's always super fun. And hope you guys have a great week, and I'll see you next Wednesday.